Hello everyone, my name is Zishan, and today we're going to look into another question from the chapter Kinematics. The problem is that there's a motorboat of mass m, which is moving along a lake with a velocity v naught, and at this moment the engine of the boat is shut down, and that there is a resistance of water which was found to be equal to F equal to minus RV, where R is a constant and V is the velocity, and it's with a velocity moving along with a velocity V naught, and it is resisted by the lake, by the water in it, and at this point the engine is stopped, so it moves till here on its own, and it stops. So let us assume that the distance that it travels on its own is given by t, and the time it takes to stop is given by t. Okay, here the velocity is obviously 0. Velocity is equal to 0. Now what they've asked us is to find the time it takes to stop, the distance it travels, and we have we've been asked to express velocity as a function of distance. Also, they say that if the velocity, which has obviously turned out to be 0 here, if somewhere in between, like say here, the velocity uh, assumes the value v naught divided by eta, we have to find the average velocity, the mean velocity during this time of travel from here to here. Okay, so we'll start with the very basic equation, that force can be expressed as mass into acceleration. The only force that the boat is experiencing is minus RV, and acceleration can be written as V dV by ds. And in case you don't know how, I'll show it to you here. Acceleration can be written as dv by dt, which can also be written as dv by ds into ds by dt, which you see ds by dt can also be written as velocity. So we have acceleration equal to v dv by ds. Now, this implies that v from both the sides can be cancelled, and we have minus r by m ds is equal to dv. Now we will integrate both the sides. dv, we are going to integrate from v naught to our velocity v, and minus r by m integration ds, we going to integrate from 0 to s. So we arrive at v minus v naught is equal to minus rs by m. So, okay. Now this can also be written as v is equal to v naught minus rs by m. So we have a equation which is which shows us velocity as a function of distance s. Also, we will use the same equation, f is equal to ma, and uh, we can rewrite this equation as minus rv is equal to m dv by dt. This gives us minus r by m dt is equal to dv by v. This implies that now we're going to integrate again from v naught to our value v is equal to minus r by m from time equals to 0 to time equals to t. Now this gives us ln v divided by v naught is equal to minus r t divided by m. This gives us v by v naught is equal to minus rt divided by m, which gives us v is equal to v naught times e to the power of minus rt by m. So we have another equation which uses, we'll name this one, and we'll name this equation 2. Now, so we'll come to the questions now. What was the first thing that they asked? They asked us the time it requires to stop. Okay, so we'll use the equation number 2. From equation 2, v, the velocity at the time it stops, is equal to 0, initial velocity v minus rt divided by m. So this gives us that for this equation, the solution is that time must tend to infinity. So the answer 1 is that the boat will require infinite amount of time to stop. Also, they've asked us about the distance it travels. They've also talked about the distance it travels before it stops. So um, we'll use from we'll use equation number 1. The velocity, the equation number 1, it's right here. The velocity when it stops becomes 0, v naught minus rs divided by m. This implies that s, the distance it travels, is equal to mv naught divided by r. Okay, we have another answer here. Answer number 2. So we have answered first question. We have also answered the distance it travels. We've also showed them velocity as a function of distance. Now we're gonna go into another problem, which is if v equals to v naught divided by eta, what is the mean velocity during this travel? Okay, if the velocity reduces to v naught divided by eta, what is the mean velocity during that time? Okay, what are the things that we know? We know that v is equal to v naught e to the power of minus rt by m. That is our equation number 2. So we'll use this. The velocity in this case becomes equal to v naught divided by eta equal to e to the power of minus rt by m. This gives us 1 by eta is equal to e to the power of minus rt by m. Now we're going to take natural logs on both the sides. Ln 1 by eta is equal to ln e to the power of minus rt by m. For those of you who don't know what natural log is, it's simple logarithm with the base e. E is the Euler's number. Now ln 1 by eta can be written as ln eta to the power of minus 1, which can also be written as minus ln eta. Ln e to the power of minus RT by m turns out to be RT by m. Now the time comes out to be m ln eta divided by r. So the time the boat takes to achieve a velocity v is equal to v naught divided by eta, that time is here. Okay, now summation integration v dt divided by summation of dt. So we already know it's v naught e to the power of minus RT divided by m, integration from time equals to 0 to a time equal to m by r ln eta divided by summation of dt from time equal to 0 to a time m by r ln eta. See, we are only talking about the time that the velocity reduces to a value v naught divided by eta. Okay, so we are putting the limits accordingly. The time we've already calculated is equal to m by r ln eta. So we're going to use that. So this turns out to be v naught into minus m by r e to the power of minus RT divided by m from m by r ln eta. Now this is m by r ln eta. This is equal to v naught m by r from the denominator, and from the denominator and the numerator both cancels. We have minus v naught, and then we put the limits. It turns out to be e to the power of minus r by m into m by r ln eta minus e to the power of 0 divided by ln eta. So this becomes mean velocity now becomes minus v naught into e to the power of ln eta to the power of minus 1. This minus sign, it's going to stay, and then we have minus 1 divided by ln eta equal to v naught into 1 minus 1 by eta divided by ln eta is equal to v naught into 1 eta minus 1 divided by eta ln eta. So these were the 4 answers that we were looking for. The first one, velocity as a function of distance, and that amount of time it takes is going to be infinity. And then we have the distance traveled, and then we have the mean velocity. Okay, these are the 4 answers. We'll look into another question. The concept that we used was actually nothing extraordinary. This is the only thing that we saw, which was a little different than usual for us. Everything else was simple. So for now, you have a good day. I'll see you in another problem soon. Bye.